第一4号分離。 X バンド防衛通信衛星3号機分離。
導き6号機分離。
HTVX1 分離。
皆さんがご覧になっているのは H3 ロケット
This is the H3 launch vehicle flight number 6, the 30 configuration test vehicle. Today, a new challenge begins here at the JAXA Tanegashima Space Center. The launch is scheduled for approximately 9:53 a.m. Good morning to everyone watching the live broadcast. This mission of the flight number 6 marks a major milestone for the H3 program. First, following the launch failure of the number 8 H3 launch vehicle test of December, this flight incorporates the findings of the failure investigation. Second, this is the first flight of the 30 configuration that does not use solid rocket boosters, the first of its kind for a Japanese large liquid-fueled rocket. Today, we'll be following the launch of the 6th H3 launch vehicle with all of you. Hello again. I'm Misaki Adachi from the Space Transportation Technology Department. My usual duties include maintaining and enhancing H3 launch vehicle systems, as well as maintaining rocket schedules and fixtures. Thank you very much. And actually, I'm Naoki Nagao, a JAXA engineer, and I'll be providing today's technical commentary. Thank you for joining us. Mr. Nagao, in April, the Artemis 2 mission, the first crewed lunar flight in nearly 50 years since Apollo 17, was successfully completed. More recently, NASA announced plans for a lunar base, and actually I was quite excited. And also, NASA the announced plan for a lunar base and marking another major development in the lunar exploration. Yes, actually, such kind of, the news made me very much excited. And actually, in addition to crewed mission to the moon and Mars, the space industry has been experiencing rapid global growth in recent years, driven in part by the expansion of the commercial satellite launch market led by private companies. And among them, actually, the H3 launch vehicle flight number 6, 30 configuration test vehicle. This is a new challenge to make a comeback and a challenge to advance new technologies. As Japan, well, and actually, today's live broadcast is also available with English simultaneous translation. And please find the link in the YouTube description below.
Today's live broadcast is also available with English simultaneous translation. Please find the link in the YouTube description below.
Now, let me give you an update on the current situation on Tanegashima as the launch approaches. Let us start with Launch Control Center, LCC. At the center, they conduct different duties required for the launch, from checking whether fuels are filled properly or the control equipment is working properly, to reconfiguring the programs if necessary. You see quite a lot of staff members sitting there, but each one is in charge of a specific job, and in the center, you'll see the launch director. Next, we have Range Control Center, RCC. This center works in collaboration with the LCC. They also make preparations for the launch and Once after the liftoff, it tracks the launch vehicle, so it plays an important role. You'd see people jumping up with joy whenever a launch is successful. That is in here. The live broadcast of the launch is also done from here. Now, behind us is the launch pad for the H3 launch vehicle. We are currently broadcasting from the Tanegashima observation stand, located about 3 kilometers from the launch pad. As for today's weather, well, yesterday we saw some clouds when the vehicle was being transported, but today it's rather windy, but it's quite fair. It's a wonderful weather for rocket launch. Well, Mr. Nagao, could you tell us about the weather conditions required for a rocket launch? Yes. Before a rocket launch, we monitor wind, rain, cloud cover, and other conditions right up until launch time to ensure that all launch safety criteria are met. Well, we just monitor from just several days before the launch. And this time it was originally scheduled for the June 10th, but the weather conditions were not met, so it was postponed to be launched today. So as you can see, in fact, launch delays are more often caused by weather conditions than by problems with the rocket itself or the launch facilities. Delays are particularly frequent due to what is known as the ice layer, a cloud layer that poses a risk of lightning striking the rocket. To accurately determine which cloud conditions are safe for launch, we at JAXA are also conducting research on the ice layer. By measuring the electric fields within clouds using aircraft and with some small holes bored into the aircraft itself, so we can stick out some sensors and we measure these electric fields. Based on this data, we refine our decision criteria. So this way we could cut down the probability of launch delays by half. So not only the rocket itself, but operational technologies like these will also be crucial as we increase the frequency of launches in the future. So these operational technologies are crucial, really, for a successful launch. Well, thank you for your explanation. Actually, one would think that the rocket itself or launching technology are crucial, but these operational technology are really helpful in making a successful launch. I see. Well, now let me briefly introduce today's broadcast. First, we'll introduce the H3 launch vehicle and the 30 configuration, which is being launched for the first time in this launch. Next, we'll discuss the investigation into the cause of the number 8 launch vehicle failure and the role of the number 6 launch vehicle, along with footage of an interview with project manager Arita. After that, we'll introduce the onboard satellites and the flight plan before the launch at around 9:53 a.m. During the live broadcast, we'll follow the mission through second engine cutoff 1, which is SECO 1, and the separation of SpaceX and Petrel.
From here, let's begin with an introduction to the H3 launch vehicle. And the H3 launch vehicle was developed as Japan's next-generation flagship launch vehicle, but actually designed to be internationally competitive and to enable Japan to continue launching satellite and space probes. It was developed as a success successor to the H2A through collaboration between JAXA and domestic companies with the goals of achieving flexibility, high reliability, and lower cost. Mr. Nagao, could you tell us about the features of the H3 launch vehicles? Well, actually, the H3 launch vehicle has multiple configurations to accommodate the wide range of the satellite and missions. And here I'd like to show you with this model. And this one, actually, the H3 rocket, and the number 630 configuration, as you can see. Very simple structure. And other than that, as for the H3 rocket, 2-2 and also 2-2 configuration and 2-4 configuration. There are 3 ones, and actually each figure means that it's first of all, actually it's a little difficult to see, but anyway, here is LE9. This is the rocket in one, and also actually this is also the solid rocket booster, and actually the number 2 is this number of this rocket booster, and also the 2-2 configuration is LE9. The engine is 2, and actually such kind of means. And this time, for the first time, that we are applying 3-0 configuration. This means that LE9 engine is 3, and there is no solid ones. Therefore, actually, the structure is quite simple. However, as for the capability of the launch, actually, this is actually this is quite strong, because actually this can be set on using the solid rocket boosters and offering a payload capacity of the 4 tons of sun synchronous orbit. Thank you very much. And actually, thank you. Since the 30 configuration is Japan's first landed liquid-fed launch vehicle to fly with as solid rocket boosters, I'm personally very much looking forward to today's launch. And to date, so far 7 H3 launch vehicles have been launched, and after the failure of the first test vehicle, the second test vehicle achieved the program's first successful launch, followed by the 5 consecutive successful launches. However, the 8th launch vehicle launched last this month failed. And from here on, I will explain the investigation into the causes of the H3 8th launch vehicle failure and how this 6th launch vehicle launch is positioned within the H3 program. Last December, the 8th H3 launch vehicle failed when the second bang of the second stage engine did not start properly, preventing the satellite from being placed into its intended orbit. Following that failure, investigations into the cause and the development of countermeasures have been carried out. As a result, this 6th launch vehicle is positioned as a mission that represents both a comeback and a challenge to new technology. And we spoke with project manager Arita about the thinking behind this decision. Please watch the video.
ではここからは H3 ロケットプロジェクトマネージャーの有田誠さんに今回6号機に至る経緯とこのフライトに込めた思いについて直接お話を伺います。有田さん、よろしくお願いします。
よろしくお願いします。
昨年12月の8号機の打ち上げからおよそ半年が経過しました。本日の打ち上げを迎えるまでどのような思いで原因究明に取り組まれてきたのでしょうか。
はい、8号機では最終的に衛星を予定した軌道へ届けることができず、多くの関係者の皆様にご迷惑とご心配をおかけしてしまいました。失敗の直後からまずは何が起きたのかを正確に把握すること、そして先入観を持たずに客観的なデータに基づいて判断することを最優先に原因究明に取り組んできました。ロケットは飛行後に実物を回収することができませんので、限られたテレメーターデータや映像データ、こういったものから飛行中に何が起きたのかを一つ一つ積み上げながら確認していく必要があります。今回は特に構造の内部で起きた現象を推定する必要があり、難しい原因究明となりましたが、追加解析や再現試験を重ねることで原因を絞り込むことができました。この半年でここまで至ることができたのは JAXA 内外の関係者、関係企業の皆様、そして衛星関係者の皆様のご理解とご協力によるものでありました。改めて感謝申し上げます。
まさに総力を挙げた原因究明活動だったんですね。 その結果特定された8号機失敗の原因について教えてください。
はい、8号機失敗の直接原因は衛星を搭載する構造の一部である PSS 衛星搭載アダプターにあった可能性が非常に高いと考えています。 PSS は CFRP とアルミハニカムコアのサンドイッチパネルを複数結合して製造していますが、その製造工程の中で一部に想定以上の温度上昇が発生し、 CFRP とアルミハニカムコアの間に剥離が生じてしまっていたということが分かりました。その剥離が飛行中のフェアリング分離時の衝撃によって進展し、最終的に PSS 全体の破壊につながった可能性が高いというふうに考えています。
PSS 内部の剥離がフェアリング分離の衝撃で進展し、 PSS 全体の破壊を引き起こしたということですね。この剥離は製造工程で生じたとのことですが、工程に問題はなかったのでしょうか。
はい、製造や検査の工程自体はこれまでの開発試験を踏まえて確立した手順に基づいてきちんと行われていました。一方で H3 で新たに採用した技術であったからこそ、設計や工程を確立していく開発過程においてより慎重に確認すべき点があったというふうに考えています。新しい技術に挑戦する以上、開発の過程で得られた教訓を次に確実に生かしていくことが重要だと受け止めています。
原因究明を受けて6号機にはどのような対策を講じたのでしょうか。
はい、8号機の原因究明結果を受け、 PSS の結合方式について検討を行いました。現在はボルトで結合するファスナー結合方式と、今回6号機に適用する補修方式の2つを進めています。6号機で採用する補修方式は、必要な補修と検査を行った上で十分な強度があることを確認しています。また今回の6号機では追加の飛行データを取得することで原因究明結果の妥当性を確認し、後続ミッションの確実性につなげていきたいと考えています。
続いて6号機のミッションについて教えてください。今回の6号機は30形態試験機ですが、どのようなロケットなのでしょうか。はい、
H3 ロケットは多様な衛星やミッションに対応するため複数の機体ラインナップを用意しています。今回の30形態はその中で最もシンプルな形態で、固体ロケットブースターを使用せず3機の液体ロケットエンジンのみでリフトオフする日本初の大型液体ロケットです。今回の6号機はこれまでの固体ロケットブースター付きの22や24形態とは異なり、大きなシステム変更を伴う30形態としての初飛行となるため、性能確認用ペイロード BEP5 を搭載し飛行実証を行います。また小型副衛星6機にも打ち上げ機会を提供いたします。
今回の6号機には8号機の原因究明の反映と新しい挑戦、その両方が込められているんですね。改めて今回の打ち上げに込める思いを教えてください。
はい、昨年の8号機の失敗により大切な衛星を喪失し、また多くの後続ミッションにも打ち上げをお待ちいただいている状況です。その中で今回の6号機は原因究明をより確かなものにして後続ミッションへの道を切り開くという再起に向けた挑戦と、30形態試験機がもともと持っている日本の大型ロケットの新たな技術への挑戦という2つの使命を背負った重要なミッションです。特に今回初飛行となる30形態は固体ロケットブースターを使用しない日本初の大型液体ロケットです。 H3 ロケットの機体ラインナップを完成させる重要な形態であり、今後より幅広い打ち上げニーズに応えていくための大切な一歩になると考えています。本日の飛行を通して国内外の宇宙開発利用を支える基幹ロケットとして一歩ずつ着実に信頼を積み重ねていきたいと考えています。
では最後にライブ中継をご覧の皆様へのメッセージをお願いします。
はい、H3 ロケットはこれからも改良と検証を積み重ねながらより信頼いただけるロケットを目指していきます。本日の打ち上げをぜひ最後まで見守っていただければと思います。
本日はありがとうございました。
ありがとうございました。
You've watched an interview with Arita Project Manager. Now I'd like to add a few details about the payload support structure, PSS, which Mr. Arita mentioned in the video. Mr. Nagao, in simple terms, what role does the PSS play? The PSS is the structure that connects the launch vehicle to the satellites. It serves as a kind of mounting base. As you can see in the video, there's a black part in the middle. That's the PSS. During launch, it is critical component that transmits the launch vehicle's thrust to the satellites. So, in the case of the number 8 launch vehicle, detailed analysis and the verification of the PSS-related phenomenon have been conducted, correct? Yes, we have been investigating the cause based on this flight data and the ground tests. As Mr. Arita mentioned earlier, the number 6 launch vehicle will use a newly developed ultra-small satellite adapter, PAF, to provide launch opportunities for 6 microsatellites. Could you elaborate on that? Yes, the main mission of the number 6 launch vehicle is to demonstrate the flight performance of the 3-0 configurations by placing the launch vehicle into orbit. To support that mission, it carries payloads for performance evaluation. That's called VEP5, Vehicle Evaluation Payload. In addition to this, we plan to carry 6 microsatellites from 5 organizations that understood the mission of the 3-0 configuration test vehicle and expressed their intention to have their satellites carried out on this mission, placing them into a sun-synchronous orbit. We will install a newly developed ultra-small satellite mounting adapter on the H3 launch vehicle and launch 6 microsatellites on it. Each port on this ultra-small satellite mounting adapter can accommodate an ultra-small satellite weighing up to 100 kilograms and measuring approximately up to 80 centimeters in height and 60 centimeters in both width and length. I see. So this time only the secondary satellites will be carried, not the primary satellites. Right. So, for payload, we have 2 groups of secondary satellites, 2 units of innovative satellite technology demonstration test machine number 3, developed by R&D team from JAXA, and 4 satellites from the private sector, provided by Space BD. So, on the right-hand side, we have 3 satellites in a table. So, there are 4 satellites actually. We have a video explaining the secondary satellites being carried, so please take a look.
JAXA 研究開発部門超小型衛星宇宙実証研究ユニットの小松豊です。JAXA の革新的衛星技術実証プログラムでは、民間企業や大学、研究機関が開発した部品、機器、超小型衛星キューブサットに宇宙実証の機会を提供することで産業競争力の強化、人材育成を目指しています。その革新的衛星技術実証プログラムの3回目、3号機の実証テーマである2つの超小型衛星の打ち上げが目前となりました。1つは革新的なマルチスペクトルカメラを低コストでありながら高性能な超小型衛星に搭載して打ち上げる陸海域分校ビジネス実証衛星海ツバメペトレル。もう一つは宇宙空間でテザーを 1km 進展しネットによるデブリ捕獲実験を行う宇宙テザー利用技術実験衛星スターズ X です。超小型衛星ペトレル、スターズ X の活躍に期待しています。
東京科学大学の八津陽一です。海ツバメ衛星は2つの全く異なるミッションが相乗りしています。1つ目は我々の衛星を社会に役立てる挑戦で多波長センサーを用いた地球観測ビジネス実証実験を行います。本衛星は特に沿岸海域の撮影に最適化されたセンサーを搭載しています。2つ目は私が天文学者としてどうしても実現したかった紫外線天体観測です。視野50平方度の高視野望遠鏡で紫外線波長域では世界で初めてとなる突発天体のサーベイ観測を行います。 この衛星開発が始まって6年、紫外線衛星の着想から10年も経ってしまいました。最後の充電の時、衛星の前に座って眺めていましたが、かっこいい衛星だなと思いました。地球観測につきましては、打ち上げがスタートになります。我々海つばめチームでは衛星だけではなくてドローンなどの地球観測装置、それからクラウドストレージ、さらにはデータ解析アルゴリズムまで含めて衛星データを社会にどうやって実装するかに主眼を置いて開発してきました。打ち上げの後はその実証することになります。これは産学連携だからできることで、大学だけではとてもできることではありませんでした。紫外線観測については、この打ち上げが成功すれば紫外線の波長帯としては世界で初めての広域サーベイとなります。光赤外線天文学大学間連携オイスターの観測ネットワークと連携して宇宙の謎に迫りたいと考えています。この衛星は学生たちが作りました。コンテナに入れるその最後の瞬間まで全く油断することなく開発や試験を完遂してくれました。もう技術とかそういうレベルではなくて思いが詰まった衛星です。必ず成功すると確信しています。
静岡大学の能見正弘です。スターズ X はテザーの実証ということで、テザーを 1km 伸ばすということを挑戦します。 1km 伸ばすと安定すると言われているので、そこができればいいと思っていて、で安定すれば次にクライマーと呼ばれるテザー上を動くロボット、それを動かす。でそれを動かすことによってテザーを自在に操れるようになればいいなと思っています。で喫緊の課題としては宇宙デブリ問題になってますけれども、それを捕まえるということでテザーで作ったネット網ですね、これでダミーのデブリを出してそれを捕まえるというような実験をしようと思っています。結構な長い時間開発してきてて十分できているのかなというふうに思っています。ただ卒業してしまっていってる学生、最初に関わった学生なんかはもう就職して第一線で活躍してるんで、それでも打ち上げなんかは見てほしいな、またミッション成功を見てほしいなと思ってます。テザー、これは微小重力だと不安定になってしまうんですね。そこをやっぱり大学衛星ということでまず果敢に挑戦していって使えるんだよということを、実証してクレーンとか橋とか大型構造物の支えとかそういうふうに利用できていたらなというふうに考えています。スターズ X はこれまでの中で一番大きな衛星、一番長いテザーロープはイヤーを伸ばします。成功させますので、ぜひ見守っていただければと思います。
こんにちは、スペース 3D の小島です。この後ご紹介する衛星は私たちスペース 3D のサービスとして H3 ロケットの間で技術調整を行い相乗り枠をご提供した日本の基幹ロケット初の事例です。それでは放出順にご紹介いたします。
Unseenlabs est une entreprise française fondée en 2015. En 2019, nous avons lancé Bro 1, notre premier satellite. Depuis, nous sommes devenus un leader mondial de la détection des signaux radiofréquences depuis l'espace pour la surveillance maritime. Nous avons environ 130 collaborateurs entre la France, les États-Unis et Singapour. Nous sommes fiers que Bro 22 soit le premier satellite d'une entreprise privée étrangère lancé à bord de la fusée H3 de l'agence d'exploration aérospatiale japonaise avec une intégration effectuée par SpaceX. Il fera très bientôt partie de notre constellation qui repose sur notre technologie monosatellite exclusive. Chacun de nos satellites fonctionne indépendamment des autres. Sa mission sera également la surveillance maritime. Nos données RF permettent de détecter les activités illégales en mer et d'offrir une vue d'ensemble du trafic maritime mondial. Le Japon est un partenaire stratégique pour la France et pour Unseenlabs. Nous sommes heureux de lancer Bro 22 à bord de la fusée H3 et de travailler avec la JAXA et SpaceX sur cette mission. Dans les prochains mois, nous lancerons nos premiers satellites de seconde génération pour continuer à développer la constellation d'Unseenlabs. Nous sommes fiers de faire partie de cette mission. Cela témoigne de l'importance de nos partenaires japonais et le caractère stratégique de cette relation. Ganbarimasu.
バーテックスプロジェクトマネージャーの佐野圭です。バーテックスのミッションでは約 10cm×20cm×30cm の超小型衛星により可視光の波長で宇宙背景放射を観測します。宇宙背景放射とは宇宙の始まりから現在までの天体からの放射の足し合わせで宇宙の天体形成の歴史を解明するために重要です。これまでの観測によって近赤外線の宇宙背景放射は基地の銀河の足し合わせより数倍も明るく謎の光の存在が疑われています。このような謎の光の起源として宇宙初期天体または近傍宇宙の銀河ハロー浮遊星などが提案されており、これらの天体の放射スペクトルは可視光の波長で大きく異なることが予想されています。そこでバーテックスでは可視光での宇宙背景放射観測を実施し、謎の光の起源解明を目指します。本ミッションでは光子や望遠鏡を搭載し、1年間で全天の 40% 以上を観測します。観測時には高精度な姿勢制御による長時間録音で天文画像を取得します。バーテックスでは超小型衛星の機動性を生かし、迅速な科学成果創出を目指します。今回のミッションの経験成果をもとに、今後も超小型衛星による最先端の天文学研究に挑戦していきます。
こんにちは。今回の打ち上げで人工衛星を実証させていただきます株式会社フルと申します。弊社ですね、栃木県の宇都宮市に拠点を置きまして、帝京大学発ベンチャーという形で今大体50人ぐらいの規模でやらせていただいています。ミッションは我々が今回デブ対策装置を軌道上で展開するというのがミッションの全てになるんですけれども、具体的にはホーンといわれる、そのですね、の右と左で L と R、右と左のホーンを実際に人工衛星の方に突っ込みまして、この突っ込んだ人工衛星を軌道上で放出させると。そうするとこの人工衛星が軌道に残るわけですけども、この人工衛星から大きな三角形の膜を広げまして、実際にそれが広がるかというのを確認するのがミッションのメインです。これが広がった先にですね、軌道上の大気を捕まえて、普通に衛星を上げるよりも早く落ちてくるかどうか、ここまで検証するのが今回のミッションの手段だったんです。ロケット、人工衛星両方に対してレベルになる前からですね、予防するための先付けの装置というのを使っています。さらにコンポーネントとしては一つ完成を見ると思ってますけども、もうこれを活用して軌道上実際展開する我々の装置からですね、新しいデータを取ったりとか、それを活用したサービスというのを考えています。
なお、複数衛星を1箇所にまとめて搭載するインターフェースプレートや複数の光子信号を電気的に制御するシーケンサーも中央エンジニアリング社およびオランダ IC スペース社のご協力の下で実現に至りました。この初めての H3 ロケット相乗り打ち上げサービスは多くの初挑戦が詰まったミッションで宇宙産業にとって非常に重要な一歩です。当ミッションの成功、そして宇宙産業の今後にご期待ください。
You have just seen an introductory video of the satellites to be launched. I found it interesting that each satellite is designed with a specific philosophy and purpose in mind as they each undertake different missions. Indeed, each satellite's mission was clearly defined and they are really interesting. And we reaffirmed the wide range of applications for microsatellites. Yes, indeed. So, if more people can take on space development as new players like this, I believe the base of space development will broaden even further, and it will become even more exciting. Yes, exactly. By the way, during this live broadcast, we will confirm the completion of the first burn of the second stage engine and the second stage orbit insertion. And using H3-30, which allows us to monitor the rocket status in real time via telemetry, we plan to watch with you until the release of some of the microsatellites. Well, as time is drawing nearer to launch, we will now present today's flight plan.
Well, we just watched the flight sequence video, and actually, as for the 3-0 configuration, LE3, LE9 engine will be activated, and also we have to check if the LE engines are activated, and such kind of test CFT is done twice. And Mr. Nagao, please let us know why were these tests conducted twice. Well, first of all, actually in the development of the H3 rocket, we conducted thorough ground testing based on the principle of test as you fly, fly as you test, and based on these principles. Therefore, actually in this time, we thoroughly conducted the test on the ground. And actually, as for the first CFT was conducted in July of last year, and the data analysis after the test revealed that the first stage hydrogen and oxygen tanks did not reach the specified pressure. Therefore, after investigating the cause, we implemented measures such as increasing the flow rate of the gas used to pressurize the tanks, and conducted a second CFT in March of this year, confirming that the pressure in the first stage hydrogen and oxygen tanks could be controlled as expected. And furthermore, we also use the opportunity of the second CFT to acquire data that will lead to further improvement in the future operational efficiency. I see. It was very clear from your explanation that you had made a thorough preparation leading up to today's event, and that the second CFT not only improved upon the first but also led to the further refinement. Thank you very much. Then let's review the flight plan again. Okay, now I'm showing this. This is today's launch sequence, and after liftoff, about 3 minutes and 12 seconds satellite fairing will be separation. And also 34 seconds later, first stage engine combustion shutdown, and after that, first and second stage separation, and also around 3:54, second stage engine first thrust rise, and after that, second stage engine first combustion shutdown. And after the liftoff, around that, the second stage engine first combustion shutdown, and 16, petrol stage X separation will be done. Thank you very much. Then, please watch this video summarizing the journey of the H3 launch vehicle flight number 6 up to today. Now the launch of the H3 rocket is imminent. Now let's take a look at the RCC just before launch. Mr. Naga, what do you think? Well, actually, they have a very, the good kind of tension there. Maybe I'd like you to enjoy such a good, nervous feeling with us. And from here now on, let's follow along with this live from the launch site and live audio commentary from the RCC.
竹崎総合司令塔より打ち上げ作業関係者に向けて打ち上げ準備状況の報告をいたします。H3 ロケット6号機30形態試験機打ち上げ最終実施判断の結果は GO です。
This reports on the status of launch preparation to operators from Takesaki Range Control Center at JAXA Tanegashima Space Center. The final decision on launch H3 is GO.
現在各系ともロケット打ち上げの最終作業を実施中です。また警戒区域の安全が確認されており、気象条件も打ち上げに支障のないことが確認されました。
Currently, all systems are in the final operations for launch. Safety has been confirmed in the restricted area. The weather conditions are sufficient and go for launch.
従いまして、性能確認用ペイロード BEP5 および小型副衛星6機を搭載した H3 ロケット6号機30形態試験機の打ち上げ予定時刻を本日日本時間の午前9時53分59秒に設定します。
We will proceed with the countdown to H3 launch vehicle flight number 630 configuration test vehicle with onboard vehicle evaluation payload 5 and 6 small satellites. The launch time will be 9:53 a.m. and 59 seconds Japan Standard Time.
560 550
打ち上げ9分前です。機体は最終的な確認作業が続けられており、現在のところすべて順調との報告を受けています。
It's 9 minutes for launch. H3 is undergoing its final check. All preparations are going well.
打ち上げ8分前より打ち上げに向けた秒読みが開始されます。
We will start the final countdown at T-8 minutes.
510、509、508、507、506、505、504、503、 502、501、500。490。
打ち上げ8分前です。現在、各系ともロケット打ち上げの最終作業を行っています。また、警戒区域の安全は確認されています。
It's 8 minutes for launch. All systems are now in their final operations, and safety has been confirmed in the restricted area.
460。450。440。430。420。
安全系準備完了。
The range safety system is go.
410、409、408、
車上系準備完了。
The range system is go.
405、404、403、402、401、400。390。380。370。
打ち上げ6分前です。現在、車上の天候は曇り、気温摂氏25度、北西の風、毎秒6メートルです。打ち上げに対し天候の影響はありません。
It's 6 minutes to launch. The current weather at the launch site is cloudy. Temperature is 25 degrees Celsius. Wind is 6 meters per second from the northwest. The weather is no constraint for the launch.
本日の打ち上げ予定時刻は日本時間の午前9時53分59秒です。
As planned, the liftoff time is scheduled for 9:53 a.m. and 59 seconds Japan Standard Time.
310、309、308、307、306、305、304、303、302、301、300。
打ち上げ5分前です。
It's 5 minutes for launch.
95、94、93、92、91、290、89、88、87、86、85、84、83、82、81、280、79、78、77、76、75、74、73、72、71、270、69、68、67、66、65、64、63、62、61、260、59、58、57、56、55、54、53、52、51、250、49、48、47、46、45、44、43、42、41、240、39、
自動カウントダウンシーケンス開始。
Automatic countdown sequence has been initiated.
現在、ロケットの管制は竹崎発射管制塔から行われています。
H3 is currently operated under the command of Takesaki Launch Control Center.
220、19、18、17、16、15、14、13、12、11、210、209、208、207、
2段液体水素地上油圧開始。
204、
Pressurization process of second stage liquid hydrogen has been initiated.
98、97、96、95、94、93、92、91、190、89、88、
一段液体水素地上油圧開始。
Pressurization process of first stage liquid hydrogen has been initiated.
打ち上げ3分前です。
It's 3 minutes for launch.
75、74、73、
一段液体酸素地上油圧開始。
Pressurization process of first stage liquid oxygen has been initiated.
機体の電源が外部から内部に切り替えられました。
The power system of the launch vehicle has been switched to internal systems.
56、55、54、53、52、51、150、49、48、47、46、45、44、43、42、41、140、39、38、37、36、35、34、33、32、31、130、29、28、27、26、25、24、23、22、21、120、19、18、17、16、15、14、13、12、11、110、109、108、107、106、105、104、103、102、101、100、99、98、97、
2段液体酸素地上油圧開始。
Pressurization process of second stage liquid oxygen has been initiated.
89、88、87、86、85、84、83、82、81、80、79、78、77、76、75、74、73、72、71、70、69、68、67、66、65、64、63、62、61、60。
打ち上げ1分前です。
It's 1 minute for launch.
56、55、54、53、52、51、50、49、48、47、46、45、44、43、42、41、40、39、38、37、36、35、34、33。
ウォーターカーテン散水開始。
The water curtain system at launch pad is activated.
27、26、25、24、23、22、21、20、19、18、17、16、15、
フライトモードオン。
The flight mode is on.
12、11、10。
下降頻等値点火。
The torches are ignited.
全システム発射準備完了。
All systems go.
メインエンジンスタート。
Main engine start.
小型副衛星6機を搭載した H3 ロケット6号機30形態試験機は2026年6月12日午前9時53分59秒に種子島宇宙センターから打ち上げられました。
We had a successful liftoff of H3 launch vehicle flight number 6-30 configuration test vehicle with onboard vehicle evaluation payload 5 and 6 small satellites from JAXA Tanegashima Space Center at 9:53 a.m. and 59 seconds on June 12, 2026, Japan Standard Time.
打ち上げ以降、ロケットの管制は竹崎発射管制塔から竹崎総合司令塔に引き継がれています。
After the liftoff, the operation control of H3 has been switched to Takesaki Range Control Center from Takesaki Launch Control Center.
ロケットは現在、東方向の太平洋上へ飛行しています。
H3 is now flying about Pacific Ocean to the east.
79、80、81。
ロケットは正常に飛行中。地上局のロケット追尾状況も正常です。
H3 flight is on
第1段エンジンの燃焼は正常、制御系飛行経路も正常です。ロケットは順調に飛行を続けています。
The first stage combustion, attitude control, and trajectory are all nominal. H3 flight is on course.
ロケットは順調に飛行を続けており、現在の高度は約 90km、秒速約 2.6km です。
H3 flight is on course. Current altitude is about 90 kilometers. Velocity is about 2.6 kilometers per second.
衛星フェアリング分離。
Confirmed payload fairing separation.
第1弾エンジン燃焼停止。
Confirmed first stage engines cut off.
第1弾、第2弾分離。
Confirmed first stage and second stage separation.
第2弾エンジン第1回燃焼開始。
Confirmed second stage engine ignition.
はい、今ご覧いただいている画面は
Now the screen you are seeing now is a CGI rendered almost in real time based on incoming data from the rocket. Well, this is the flight status indicator for public for the H3 rocket. We call it usually H3-30. This shows the rocket's direction and altitude as a line. It's a visualization of the information received from the rocket. The top left shows the speed and altitude. As you see, it shows a very high figure, but it's in kilometer per hour. But it converted into this kilometer per second. It's about 8 kilometers per second. Well, here the X plus figure shows show the time elapsed since the rocket launched.
第2弾エンジンの燃焼は正常、制御系飛行経路も正常です。現在の高度は約 400km、秒速約 3.3km です。
The second stage combustion, attitude control, and trajectory are all nominal. Current altitude is about 400 kilometers. Velocity is about 3.3 kilometers per second.
Well, Mr. Nagao, the rocket is continuing its flight. About 1 year ago, the H2A's last flight was successfully launched from here, from Tanegashima. So can we just talk about the differences between the H2A and the H3? Well, there are several differences. The most easily understand, what we can understand most easily is that the launch capacity has been increased by up to approximately 1.5 times. This increased launch capacity is made possible by the LE9 first stage engine. The LE9 has a thrust of approximately 150 ton F, which is significantly more powerful than that of the H2A. So on the other hand, by applying a relatively simple engine system called the expanded bleed cycle, reliability has been improved and costs reduced. Other than that, are there any difference between the H2A and H3? Well, this time it's a configuration Okay. In this case, it's a configuration without solid rocket boosters, but we have employed what's called a synergy development, where we share this system with the Epsilon rocket. So, building upon past technological achievement while also venturing into new technology, we are efficiently advancing development, not just on individual rockets, but on the entire core rocket system. Yes, indeed. Well, now we have a replay footage of the launch, so we can see maybe we can just touch on the difference between the rocket with boosters and the rocket without boosters. Well, we are about to see the launch. Wow, the torches are lit. Yes, LE9 has been ignited. Wow, it's so cool. Oh, it's so nice, wonderful. Well, Mr. Nagao, as we had expected, this looks a bit slower than the other rockets, previous rockets. Yes, it's felt a bit slower than the previous ones because we don't have this large solid rocket boosters to have it go up. Yes, and one thing that caught my attention is the smoke. Usually we see the thick cloud of rocket load. It's a thick cloud that remains for a long period of time after the rocket launch. But in this case, you see nothing of that cloud. Yes, obviously it's due to the absence of the rocket booster, solid rocket booster. It's clear difference that we can observe. Yes, it's a kind of interesting, isn't it? And the other thing that we paid attention to was the color of the flame that came from the engines. That because it's made of the oxygen and hydrogen, so we thought it would be quite transparent, clear and transparent. Yes, I found it. Rather than being the bluish flame, I thought that it looked rather orangish. So maybe due to the vapor and dust burning, it maybe looked orangish. Yeah, I see. Well, we can touch on that. Yeah, you can go back to the image later if you are more interested.
The second stage combustion, attitude control, and trajectory are all nominal. Current altitude is about 640 kilometers. Velocity is about 4.5 kilometers per second.
Well, regarding the H3 rocket, this time the number 6, if this is successful, all the lineup will be completed. However, the further development is underway. And actually including the improvement in the sophisticated and frequency of the launch. And why is further development necessary? Well, actually, in recent years, the demand for the satellite launches has expanded rapidly, and the rocket supply is increasingly unable to keep up. Furthermore, there is a growing demand for flexibility in launching satellite at desired times. Therefore, to meet this demand from satellite customers, the H3 rocket is working to increase launch frequency, aiming for 6 to 8 launches per year, through improvement to launch site facilities and streamlining launch operations. Also, to support multiple small satellite carrying in the constellation project, and to further enhance launch capabilities in anticipation of further large-scale exploration missions, and so on, in order to respond promptly to the rapid rapidly changing market in recent years, we are pursuing a phase upgrade of our rocket as part of our advanced development programs. And we are taking comprehensive measures to meet current demand, including operational aspects and launch site facility. I thought our phase strengthening, which includes supporting milestones for small satellites and looking forward to future large-scale milestones, was a very strategic approach. Okay, then following. Now, actually, let's see what is happening now. It seems the second engine's first combustion will finish, and as long as we can confirm that our main mission, the second stage entering into the orbit, is completed. And for the time being, let's watch this. The first combustion shutdown of the second stage engine has been confirmed. The first combustion shutdown of the second stage engine has been confirmed. We did it. We did it. Yes, actually, the detailed confirmation of the orbit insertion results will be done later. But for now, we have revealed that the second stage orbital insertion was completed as planned. And actually, after that, the role of the rocket is the separation of the 6 microsatellites in carriers, so we can't let our guard down yet. And shortly after, the ultra-small satellite Stars X and the petrol rail will separate.
Confirmed petrol separation. Confirmed Stars X separation.
Yes, it seems that separation of the micro satellite has been confirmed successfully. Yes, the first burn of the second stage engine has successfully completed, and the H3 rocket test vehicle number 6 has achieved its main mission of second stage orbit insertion. We also confirmed that the separation of the ultra-small satellite or microsatellite SpaceX Petrol. What do you think, Mr. Nagao? Yes, these two micro satellites have been deployed into orbit, so we still need to see the remaining 4 microsatellites, so we need to stay on watch. Well, for this launch, we provided launch opportunities for 6 microsatellites using our newly developed ultra-small satellite adapter. Seeing how the H3 makes access to space easier than ever before, I sincerely hope that the space will become more accessible to a wider range of people, and personally, I am committed to work hard to make that happen. Yes, I'm really looking forward to seeing what the H3 rocket achieves in the future. Well, with this launch, the entire H3 rocket lineup is now complete. However, still, we have development challenges we need to work on, such as the faster coupling method for the PSS and the development of the Type 2 for the LE9 engine. After resolving these challenges, we intend to steadily advance efforts, such as increasing the launch frequency and advanced development of the H3 rocket, and work together with all stakeholders to further boost Japan's space development. Yes, the launch results, including the placement of the second stage into orbit and the separation of the microsatellites, will be officially announced in a subsequent JAXA press release and a press conference regarding the launch progress. The press conference will also be live-streamed on the JAXA YouTube channel. For details regarding the press conference, please check the JAXA website or JAXA's official social media accounts. Yes, we ask for your continued support for the H3, Japan's flagship rocket. We also ask for your support for the new Epsilon S rocket, for which we are currently diligently working on investigating the cause of the problem and developing it for launch. Yes, we would appreciate your continued support for the H3 rocket and the Epsilon S rocket. Thank you for watching today's live broadcast of the launch of the H3 launch vehicle flight number 630 configuration test vehicle.